The simplest way to be able to control motors is just supply them with electricity. We can change the pulse width modulation on a DC motor, we can change the frequency that's going to an AC motor, but that's the simplest way to control a motor. The only problem is we have no idea whether the motor is actually responding the way it's supposed to. For this, we use a concept called closed-loop motor control. Most often, we see all the devices wrapped together in what's called a servo motor. A servo motor has both the motor itself, can be a DC or an AC motor, but it also usually has an encoder attached to it, which can track how fast the motor is rotating or what position the motor has rotated to. A closed-loop motor controller, therefore, has a lot more inputs and outputs. The inputs come from a controller that can do all the calculations of where do we need it to go, how fast do we need it to go. But it also has inputs coming back from the encoder of the motor to track its position and speed. The outputs go to the motor directly, just like any typical DC or AC motor. So these types of servo motors, or this closed-loop motor control principle, gives us way more precise control to be sure that not only are we sending the signals, but that the devices are responding the way that they're actually supposed to.